Welcome back to the fourth video of data structures and algorithm. In this video we are going to look at queues basics and implementation of queues using C++. Queues. Queue is basically an data structure. Queue is a set of memory location used to implement last in last out or first in first out concept. If you look at the real time example, it is named queue as it behaves like a real queue, like queue of cars in a single lane, or queue of people waiting at the food counter. Queue is an abstract data type with predefined capacity. It is a data structure which allows adding or removing data in a particular order, which we have discussed as FIFO, that is first in first out, or LILO, last in last out. If you look at the queue, it's a data structure which follows FIFO or LILO. Queue has two ends. One is the head or the front, the other one is back or the rear. If you look at this one, you have head or front and back or rear. These are all the two ends of a queue. Elements are added at the rear end and it is removed from the front end. So at this point the elements are added, that is, it is added from here, from the first position, second position, third position, fourth position. So always the queue starts from this point, and whenever you are removing from the queue, it happens from the front end. So this is actually a queue, and this is going to be the first element in the queue, second element in the queue, third one and fourth one. So queues has lot of operations. We will be discussing about these operations now. One is called as enqueue, the second operation is dequeue, and the supporting two functions are isFull and isEmpty. Okay, enqueue is nothing but it is a operation which is adding the elements to the queue. That is, elements are added at the rear end is actually called as a enqueue. Dequeue is elements are removed from the front end, that is actually called as dequeue. So basically enqueue is for adding the elements to the queue, dequeue is removing the elements from the queue. So we also have two support function, isFull. IsFull function is used to check whether the queue is full or not. IsEmpty is a function which will check whether the queue is empty or not. So these two functions will also help us to create this enqueue and dequeue operations. We are just looking at more details about the enqueue and dequeue. So at the rear end, and if this is going to be called as a queue, so it is an array. So an array is starting from index 0 goes to 1, 2, 3, and this array is actually of length 4. Okay, if you look at this enqueue is added at the enqueue is happening at the rear end. So if the queue is empty here, when you pass one value, that value will come to 0th position, and if you send the second value, it goes to 1 position, and third value in the 2 position, and fourth value in 3 position here. Since it is an array, it is starting from 0, 1, 2, 3. So NQ is happening at the rear end and DQ is happening in the front end. So whatever is coming here as the first element, which is available in 0, and that is going to go as in the DQ operation, that is going to go first. Whichever is coming first will go out of the queue as a first element here. Okay. So to implement this, we have two variables, one is rear and front. Okay. So and these two elements and two variables are going to be initialized to -1 in the initial stage, and as we are writing the function or as we are executing the functions NQ and DQ, what is going to happen is the rear and front variables will be incremented to the to fill up the queues. Okay. So let us look at how this is going to be implemented now. So what is the logic for that? So queue is implemented using C++ and queue is implemented using arrays. So we shall be using arrays in C++ code to implement this queue logic. Rear is actually a entrance of the queue, though through front we come out of the queue. Rear and front are two variables which is initially -1. When we are doing NQ operation, rear is incremented. When we are doing DQ operation, front is incremented. So this is the logic which we will be using it for operating the queues and implement the first in first out and last in last out. Is empty and is full are checked using these two operations, which is NQ and DQ. Now let us see how this is implemented by using C++. First we need to create a class. So first we are going to create a class here. So I have shown a part of the class here, and this class name is QDS, that is Q data structure. So in this we have three private variables, integer q of 5. So this is basically an array which is going to be considered as a queue here, and there are two variables, rear and front. So the rear and front are two integer variable declared for navigation of when the NQ and DQ operations are done. So we are going to navigate this within that particular queue when the NQ and DQ operations are done using this rear and front variables. Next we will come to the public functions. What are the functions which is available under the QDS class. So the first function, public function, is going to be a constructor. As we know, what is a constructor? Constructor is basically a function within the class which has the same name as a class. So the name of the class is QDS, and I am declaring a constructor here, QDS. In this QDS function, and that is the constructor, what I am doing is I am making the rear and front as -1. Okay, so which means that it will be like this. If this is the queue, okay, the rear and front is made as -1. It is not pointing to any of the elements available in the queue, both rear as well as front. So that is what is happening here, and there is a for loop which starts from 0 and goes up to less than 5. This is to initialize the q. So, q is declared here as q of 5. So, q of I is equal to 0, that means it is q of 0, q of 1, q of 2, 3, 4, 5 all are made as 0 here. So, basically it is initializing the array also here. So, rear as well as front. So, this is actually done using the constructor. The constructor is used to initialize the rear and front variables to -1 and to initialize the array. Next function is basically a is empty function. When the q is empty, we are making this rear as -1 and front as -1. So, when it is empty here, these two variables will be -1. Whenever there is an NQ operation happening, what is going to happen here? Both front and rear will become 0 and 0, and then whenever you are doing a NQ operation second time, what is going to happen? You will be using the rear variable to navigate from 0 to 1, 1 to 2, 2 to 3, 3 to 4 like that. So, real will be keep on incrementing here, and whenever you are doing a DQ operation, front will be taken, first element will be taken out, and then again front will be incrementing, again front will be incrementing it 2 like that. So, one by one you will keep on removing outside, the values will be removed from the outside. So, when you are writing a function called as is empty, you will be checking if the front is -1 and the rear is -1, then it will be true here, you will be returning true. So, your return value is going to be of boolean type. So, is empty will return true or false here based on this condition here. So, when the q is going to be empty, when the front and rear both are going to be -1. Next is when the q will be full, when q will be full, when the rear is equal to 4, means since we have the q as 5 elements, okay, it starts from, it's an array and it starts from q of 0, q of 1, q of 2, q of 3 and q of 4. So, all the 5 elements will be entered when the rear is going to be 4. Okay. So, when rear is equal to 4, then you return true, that means it is full, otherwise it is going to return false, that means it is the q is not full. Okay. So, when it returns false, q is not full, and when rear is equal to 4, then it will return true, which is going to be considered as q is full. The next function is going to be a very important function, which is going to be your NQ operation. As I have already told you, NQ operation is for adding the elements to the queue. Okay. So, what I am doing is I am designing an NQ function like this. NQ, you pass a value to that, okay, and it does not return any value. So, I have returned void here. So, within this NQ function, first I am going to check whether the the queue is full or not by using is full condition. So, if you are doing it for the first time, the both rear as well as front will become -1. So, it is not equal to this 4. So, it will return false, which means it is not full. So, if it is going to be full, it will say q is full here. Okay. So, if it is empty, that means if rear as well as front are -1, then it is going to be empty here. So, both rear as well as front you make it as 0 here, and you make q of 0 is equal to val. That val is nothing but what I am passing it to the function called as nq here. Otherwise, you just increase the rear by 1 and then assign that particular position the value whatever you have it here. Okay. So, this is what is going to be your nq function, which will allow you to add elements to the queue. Next is dequeue operation. Dequeue operation is going to work on the variable front. Okay. So, here I am declaring a variable called as return value. So, this dequeue function does not take any parameter here, but it returns an integer. What it is going to do? It is going to go to the array, or it is going to go to the queue, and the queue it will be always pointing to the first element there. Okay. When you are saying dequeue operation, first element which has come first into the queue will be taken out. Okay. That is the operation of the dequeue here. So, it will take the first element, later on it will increment the front to the next element, it will become 1. So, it will check whether it is empty or not, the queue is empty or not. If it is empty, then what it is going to do is it will give a message saying this queue is empty and then return 0 to it. Okay. If both both front as well as rear both are same, then return value whatever I am declaring here is equal to q of front. That means if it is going to be 4 and it is going to be q of 4, and then you have front is equal to rear is equal to -1. If both front as well as rear are same, you make front and rear as -1 and then return the value to, and you store the value of this q of front to this return value. Else you do the same operation, return value is equal to this, and q of front you store it in return value, and front plus plus, it means you go to the next element which you will be pointing to as a next element to come out. Okay. So, here you are storing the value of the return value, that is which is going to be taken out from the queue. So, that dequeue operations are happening here, and when you say return value, so whatever is the last value which was pointing to, that will come out of that particular queue. Okay. This is the dequeue operation. So, the operation, this particular function will have integer, dequeue and void. You do not pass any parameter, but it returns a value. It returns 0 value when the queue is empty. I am writing a function called as display function. This is going to display the complete set of values here, all the value whatever is available in the array. Okay. So, here I am just saying I is equal to 0, I is less than 5, I plus plus. You can also use the rear variable here. When I is equal to 0, I is less than rear and I plus plus. So, if you have only 3 elements, only 3 elements will be displayed here. If you have only 2 elements, 2 elements will be displayed here. So, you can use that one, but as of now I am using the complete array, I am displaying it here. Now, in the main program what you do is you declare an object of q data structure, that is qds, and you declare a variable called as value here. Okay. So, let us see whether how I am going to use this nq and dequeue operation. So, what I am doing is, since it is an array, I am going to declare, I am going to send 1 2 3 4 5 times here, 1 2 3 4 to the nq. So, first time I am sending 1 will come to the 0th element. When I am sending the 2, it is going to come to the second element, like that. It goes on till 5, and after that I am using this display function to display the value, all the values on the screen. Okay. Next is I am trying to add one more value here to this particular 6 value, then that time it will say the queue is full and it will not add this particular value to this queue element. Okay. So, since it is an array, we have a limited set of elements there which we declare at the time of declaration in the class itself. So, since we have declared 5 element there, only 5 elements can be added to that. The 6th element cannot be added because the queue will be full. So, when we are trying to add the 6th element here, it will display the error saying that it is full. That is, it will check this here. If it is full, it will check. This full is nothing but when var is becoming 4. When var is becoming 4, then it will say queue is full here. So, it will not enter any value to the queue, then it will come out. Okay. So, next is this is the enqueue operation, and for dequeue operation what I will do is you will take out one value from the queue, display that. So, second time when I am calling this, it will take the second value, it will take third time when I am calling, it will take the third value, fourth time it will take the fourth value, like that. It goes for the 5 elements. Okay. So, these 5 elements will be taken out, and you can when you are trying to take the 6th value out of the queue, then it will say that queue is empty here, because you have taken all the values from here. So, it will become empty. So, when you are trying to do one more dequeue operation, it will say that queue is empty here. So, this error message will be displayed when you are trying to take the 6th element from the queue, where only 5 elements are there. So, this is what we are going to see as a simple example to implement the queue, and then how to use these operations like enqueue and dequeue operations, okay, with the help of is full and is empty. Okay. So, now let us go to the code implementation and see how this can be done. So, what I will do is I will go to this one, I will take IDE 1. So, here this is actually a C++ compiler which is available in the browser itself. You can change the language which you wanted to compile. Now, since I am using C++, it will be pointing to C++ here in this place, and now you can see this is a class. So, let me write a class now. So, the class will implementation will be like this. So, we will use the same code whatever I have displayed in the PPT to implement this code here. So, class queue ds. So, this is going to be the class declaration. Next will be I am declaring the public functions, public variables, private variables, private integer queue of 5. This is going to be the queue declaration. Then I have integer rear, integer front. Then we will go to the public functions, public. So, in this public, first I will declare a public function which is going to be the constructor qds. This is the public function which is going to initialize rear is equal to -1 and front is equal to -1. Both I am declaring as -1 here. Then for integer I is equal to 0, I is less than 5, I plus plus. So in this, what I will do is, I will say q of I is equal to 0 here. I am just initializing all the elements of an q array, q declaration whatever I done, q of 5, each and every element will become 0 here, that is initialization of that. So this is what is going to be the first element, first function which I am going to write it. The next thing is empty, boolean is a return type, is empty is the name of the function, okay, and you don't pass any value to it, so you just say void. Now what I am going to do here, if rear is equal to -1 and front equal to -1, if both rear as well as front is equal to -1, what I will do is return true, it is empty, else return false. So this is what is the is empty function here, and now we will go for boolean is full. This function is going to return true or false based on whether it is empty or not. So if rear is equal to 4, so why I am writing 4 here, it is because I have declared an array of 5 elements, and the it is an array which is going to always the index will start from 0, so the fifth element's index will be 4. So when the index reaches 4, then I will say return true, else return false. So I have written 3 functions here. One is the constructor which is initializing the rear and front, okay. The other one is bool function that is going to return true or false based on the rear and front values, and you have is full function, this is going to return true or false based on the rear value whether it is equal to 4 or not, okay. If it is equal to 4, then the return value will be true, else it will be false. So 3 functions we have written here. Now we will go for so we will go for the next function called as enqueue. So the enqueue is going to be void enqueue integer value. You will have to pass the value to the enqueue function. So first you will have to check whether it is full or not. If it is empty, you do this, and if it is not empty, then you do this one. So we will use this particular function in the C++ code. So void, it does not return any value, enqueue, you will pass integer value to that. So the first thing what you do is you will check whether it is full or not. If is full, then what you will do is you will say that the queue is full. Cout is full. You cannot enter any value. That is actually the condition here. Okay. So when it is full, you will say this one. If it is empty, what you will do here, you will make rear and front as 0, and q of rear is equal to val. So what I will do, I will have another if condition. If E is empty, if E is empty, what I will do is rear and rear is equal to 0 and front is equal to 0. So both can be made as 0 here, and later on what I will do is q of rear is equal to val. So this val is nothing but it is a value which is passed to the function nq, and that value is going to be stored in q of rear here. Otherwise, if the q is not empty, otherwise what you will do is you will just say rear plus plus, and then you do the same operation, q of rear is equal to val. This is what you are going to do here in this case. So your nq operation is done here. This is going to be void nq integer value. Now we will go for the another function called as dq. So dq operation is like this. You have integer return value. So this return value I am going to use it for returning the value here, and here I am going to check whether it is going to be empty or not. If it is empty, I cannot return any value, so I am going to return 0. So first I will check if it is going to be in empty. Q is going to be, I will display a message called as q is empty and then return 0. If front and rear are same, I will take the value from the q and put it in the return value, and then make the front and rear as -1. Otherwise, I will put the value from the q to the return value and then increment the front. So this is what I am going to do it here in the dq operation. So I will write, it will return a value, dq operation is going to return value. So I will say integer dq, this is going to be void, it does not take any value to the function as a parameter. So here if I will declare integer return value, I will make it as 0 here, make it as 0 here. Now we will go for the actual function. If E is empty, as I said, when the q is empty you cannot return any value. So I will display a message cout q is empty. So no value can be returned, and ln, then I will return 0. So I will display a message saying that it is empty, and then I will return 0 here. Now next is I will have to check if front and rear are same. So I will check if front is equal to 0, sorry, both are same, front and rear are same. So front is equal to rear. Then what I will do is, in this case I will say return value is equal to q of front, and then I will make front is equal to -1, rear is equal to -1. So both I will make it as -1 if both are same, front and rear are same here. Then when the both are same, I will do these operations. Okay, and if it is not going to be same, if it is not same, what I will do is I will do the same operation, return value is equal to q of front this operation I will do it, and then I will increment front. So these two operations I will do it here. So now the return value will have the value which needs to be which needs to come out of the queue. So that value I will return it here. Return value. So this is going to be your DQ operation, and this is going to be your NQ operation, is full, is empty, and then a constructor of this particular class to initialize that. So this class has been completed now. So now we are going to go for the main function. So as I have told you, it's a simple function. Okay, there is one more function which we have forgotten. That is going to be your display function. So let us write the display function also here. Void display void. This is going to be for integer I is equal to 0, I is less than 5, I plus plus, and in this for loop I am going to say cout value then I will say I plus 1, see here q of I. So I am displaying value 1 is equal to the value first element, value 2 is second element, value 3 is third element. So since I is starting from 0, so the first element will be should be incremented by 1, so that's the reason that I am giving here. So your display will be correct when you are writing this value here, this statement. So your display function is also over. Now we will go for the main function. So main function, first I need to declare an object of this class. So you do an object, you declare an object here. So q. So I am declaring an object called as QUE. This is actually an object of this particular class. So whenever you do an object declaration here, the the constructor will be called, which is going to be the default constructor, and this constructor is going to initialize rear is equal to -1 and front is equal to -1, and it will also initialize the array what you have declared here. So that is going to happen when you declare an object. Next what I will do is I will go for the enqueuing and dequeuing here. So since it is an array, I am just using, and you have only 5 elements in that array, so I am directly using the direct statements one by one. I am executing it here. So for entering into the queue, q dot enqueue. So first element 1 I will pass. So enqueue is a function, right? So that function name should be used. So I am copying that just to avoid any mistakes of the name. So this first element will be added to the queue here when you say q dot enqueue. Okay. So if you want to add the second element, third element, fourth element, and fifth element. So now I am going to change the values. 3, 4 and 5. So you are adding 5 elements here. After adding 5 elements, you can display it here. You can display. So using this q dot enqueue, you can q dot display. So this q dot display will display the 5 values here. So till this we will just execute this and see how it is going to run. We have written the entire class here, and we have written the NQ and DQ functions, and this NQ and DQ function will take make use of E is empty and E is full. Okay, and there is a display function to display the value of the Q. So now I have declared an object of QDS, and this QDS is adding, I have added 5 elements to the Q, and we have only 5 elements in the Q also, and I have added all the 5 elements, and now I am trying to display the value here. Till this we will just see, we will run it and see the output here. So now if you look at this one, I have added 1, 2, 3, 4, 5. So your display function is displaying value 1 is 1, value 2 is 2, value 3 is 3 and 4 and 5. So if you want, you can change the values and see. Second value is going to be 20. Sorry, we need to edit it here. So when you try to edit, you can edit the code. So you take it as 10, 20 like this. 10, 20, 30, 40 and 50. Now you try to execute this one. After saving this, and you can clear the output, or you can run it now. So when you are running the output here, you can see when it is running it, it shows this. So previously 1, 2, 3, 4 I have put it in the queue, so that was displaying 1, 2, 3, 4, 5. Now I have stored the first value is 10, second value is 20, third value is 30, fourth value is 40 and fifth value is 50 here. So I have this value entered into the queue, and I am displaying that one. So now I was saying that when the queue is full, it should say an error message saying that queue is full. Okay, so I am trying to add one more element to the queue here. After 5 elements are over, I am trying to enter into this one. I am entering the 6th element. So I am trying to store 660 there. 60. So when I am trying to do this one, what is going to happen here? Already 5 elements are stored, and I have the queue is already full here. So when I am trying to do this one, this is going to display queue is going to be full. Okay. So now let us save this and run this one and see how it is happening. What is the output here? So now you see this, all the first 5 values are added, and the last one which I am trying to add is going to be this. So it is going to say queue is full. So it is not adding the 60 value into this particular thing. So this is how it will happen when you are doing an NQ operation. So DQ operation, what you are trying to do is you are taking out one by one. Okay, so let me have this 10, 20, 30, 40, 50. All these 5 values are added to the queue. So one by one I wanted to take it. How will I take it here? So the DQ operation, is going to take the value from the queue, and the value is going to be, which is going to be taken, will be always the first in first out. So first element which has come inside the queue will be taken out first. Okay, so what I will do is, if I am running it for the first time, what is going to happen here? This has come first to the queue, so it will take 10 from the queue here, and then second time it will take 20, third time when I am calling it will take 30, fourth time it will take 40, fifth time it will take 50 here. So just to differentiate, I am using cout function. So first value which I am taking it here is this. Okay, so first element. So similarly I want to take the second element, third element, fourth element, fifth element. So you can just take the values outside like this. Okay, this is going to be second, and this is going to be the third, this is going to be fourth, this is going to be fifth. Okay, so now what I am trying to do here is I have added elements to the queue, and now I am taking the elements out of the queue. So when I am calling the dequeue function for the first time, it will take whatever has come first to the queue, that will be taken out. So like that all the 5 elements will be taken out here. So I will save this and run the application. You see what is happening here. First element which has gone inside is 10, second element is 20, third element is 30, fourth element is 40, and fifth element is 50. And I am trying to add sixth element. It says that queue is full. Now when I am calling this dequeue function first time, it will take first whatever it has come first to this queue, that will be taken out. Second time it will take 20, third time it will take 30, 40, 50, like that. When it is in the queue, it goes like this and it comes like this. Okay, so you can see that all these values are taken out in the sequence of the queue here. Now again, when you are trying to do one more time, that is the sixth time when you are trying to do it, what is going to happen here, you see. So this is the sixth time I am trying to take the element from the queue. Okay, so is there a sixth element? There is no sixth element here. So what is going to happen here when I am trying to do this? You save this and then run the element here. So it has stored the values. Sixth element, it says queue is full. Now sixth element is 60. Oh, it should not happen actually. So sixth element should not be 60 here, because since we are using this dequeue operation, it should not do this one. So it is trying to take this particular thing as the last element. So when you are trying to dequeue, okay, so it should basically say that it is empty. Okay, so now let me clear this and try to take this one. So it says 60 here. So because we are not using this in the dequeue, when it is empty, -1, then it is not going to do. Queue is empty and then return 0. So basically this function should be taken. Okay, so when front is not equal to 0, so it is taking this value. So that is the reason that it is happening like this. Now when you are trying to close this and when you are running this application, so what is going to happen here? So queue is empty here. That means it takes all these things. Now you take this first element, second element, third element, and fourth element, and fifth element, it is taking it out. When you are trying to take the sixth element from this one, it says queue is empty here. That means it is returning a 0 here in this case. So that is what is the dequeue operation now. So now let us look into what all we have seen here in the example. So there is a class we have declared QDS, and there are 3 variables. We declared one queue array, rear and front we have declared. We have written all these functions: is full, is empty, and then constructor, enqueue and dequeue. And we have used this enqueue and dequeue in the main function to demonstrate the queue operations like enqueue as well as dequeue. Enqueue will add the elements to the queue, and dequeue will remove element from the queue here. So that is what we have seen now in the queue operations, dequeue operations. In this video we have seen about the queues in C++, the implementation of queues in C++, and queue is implemented by using arrays. So here in this video we are not looking at the big O notation, because since we are using arrays, there will not be much difference in the big O notification, big O notations. So we will see the big O notation when we are trying to implement stacks and queues in using linked list. So in the next video I will be looking at the linked list, single linked list and double linked list, and we will also discuss more on the big O notation on when the linked list and the single linked list and double linked list is implemented. So we will implement both stacks and queues using linked list, and we can discuss about the big O notation there. Thank you very much.